the mini to the call all, and the length of it is 13, and the count of each vowel letters. So for example, A, E, I, and O, and yeah. So there are 2 times of E, 2 times of I, and 2 times of O, and 0 time of A and U. So the longest length is 13. So we want to, we just want to meet the conditions. So return the size of the longest substring containing each vowel an even number of times. So this means, it can be 0 or 2 or 4, but it must be even number of times. And we want to get the longest substring to meet the conditions like that. So for the second example, maybe it is just lit with C, because there are 2 E's, and we can see there are 2 E's. And the longest length is just 5, and we cannot find a longer one. Maybe you want to find a longer one to here O, but it is not okay because there are 3 vowels. We just need to meet even, because there's only 1 O. There's no 2 O's. We just need to meet for each of the vowel characters. It must be even times. If you are familiar with this kind of a pattern, so this is the prefix sum, but basically we're gonna use a bit mask. The prefix, I'm gonna call it a prefix XOR to solve the problem. Normally, it is a bit mask problem. So this problem is similar to a Leetcode problem 1542. Find the longest awesome substring. So I posted a video for this one. If you are not familiar with this kind of a pattern, maybe you're gonna practice this question first. Because in this question I explained in detail about each of the steps, why we should do it like that. But for our problem, I will explain. I will basically play all of the steps how to approach such kind of a problem. Basically we are just giving a string, and we want to calculate the longest length of the substring, which will meet some conditions, and this conditions is for the vowel characters. So for each of the vowel characters, it must be even times. At first I read the question wrong. I read the description wrong. So I understand maybe the total number of vowel characters must be even. Actually, it is wrong. It is not like that. It means for each of the characters, it must be even. But the pattern is just the same. We're going to use a bit mask to solve it. It is just like that. First of all, we're going to make an encoding of A, E, I, and O, U. Because the length of the string is 10 to the power of 5. 5 times 10 to the power of 5. Basically, we want to solve it. I forgot. Let's just check the length of the string. So the length of the string is 5 times 10 to the power of 5. So basically, we can use another 5 as the actual time. So 25 times 10 to the power of 5 is okay. This is why we're going to use a bit mask. So we have 5 characters, A, E, I, O, U. So we only consider those 5 characters, because we don't need to consider other characters. We just need to count for each of the characters. For those 5 characters, it must be even number of time. So first of all, we're going to encoding. So for A, we're going to encoding as 0, E as 1, I as 2, O as 3, and U as 4. So there are only 5 bits. And then we're going to check for each of the operations. Maybe I'm going to try to use a shorter example. Maybe I'm going to just use lit. Let's just check lit with C and O. Maybe, because this example is shorter. It can save some time to explain it. So basically, we're going to check each of the characters. But before that, we're going to prepare an initial state. So we're going to use a mask to explain the initial state. Because the length of the vowels A, E, I, O, U, there are only 5 characters of vowels, so it's going to be 5 zeros. So this is going to be the initial state. So this is my mask. It's going to be always be zeros. Now I will check characters one by one. So for this character, so what is that? So this is a not vowel. So I will not check it. I will not check that because this is okay. Yeah. And also from the beginning, I'm gonna prepare a hash table, but I prefer to use an array to represent the hash table. So the index of this index array, so the index is the state, it is the mask, and the value is the index of the string. So for the first one, it is L. Yeah, but from the beginning, I'm gonna prepare a padding. It is -1, and for the first one, so yeah, for the first one, yeah, this is for index 0. It is -1. Yeah, basically we don't have this kind of state. This is our initial state. And then we are checking all the characters. We will not have this kind of state. Basically, yeah. But even we have this kind of state, it is okay because we will ignore the characters which is not vowel. So for the first one, this is L. It is not vowel. So we will just ignore it. Yeah, we just ignore it. But we're gonna still check the result because even this is not vowel, it is okay. The length is 1. It is still okay. Yeah, but let's just check the second character first. Let's check this E. Yeah. So while we are checking this E, it is at this position. So the position of this character E is 1. So for here, so what are we gonna do? So for L, we didn't do anything. So this is L. Yeah, we still have zeros. So what about E? So for this E, it is at the second position. So we're gonna update it to 1. So it's gonna be like this. So this is for the character E. Yeah, yeah. Let's just check what happens. So for the next E, we're gonna still use XOR with this one. So for the next E, it is 0, 0, 0. Yeah. While we are using XOR 1 XOR 1, it's gonna become a 0, 0. As you can see, there are 5 zeros. Here also 5 zeros. This means the final result 0, 0 is the same. So if it is the same, we're gonna check the result. So as this is -1, this is index 0, 1, 2. So what is the length? So the length is 3. So currently we get a result of 3. But even for this L, we're gonna still get the result. It is 1, but it's not the maximum. Yeah. Now we are going to check the next one, maybe T. T, we will not update anything. We just keep it as this E. So it's gonna be 0, 0, and 0, and it's gonna be index 3. And then we're gonna check index 4. It's gonna be C. So C is not vowel. It is okay. So it's gonna still be 0 because the state, we will not update the state. Only if this character is vowel, we're gonna update the state. If it is not, we will not update the state. So it's gonna be the same. But currently, what is the longest length? It is 4 minus 1. It is 5. So this is our final result. It's gonna be 5. Yeah. So for the next one, maybe we're gonna check this O. So it's gonna be index 5, and it is character O. And where is the position? It is 3. So this is gonna be 0, 0, 0. Yeah, 3. The position 3. Here gonna be 1. Here is 0. Can we find another number which is 0, 1, 0, 0, 0? We cannot find. There's no such numbers. So what are we gonna do? Yeah, we're gonna set it as infinity. So it means we will not check it. Basically, because we set it as infinity, it means some number may be n minus infinity. It's gonna still be negative infinity. We're gonna still record the previous result. It's gonna be 5. Yeah, so this is the whole operation of the problem. So if you are not familiar with this kind of pattern, maybe you can check my YouTube solutions for this one, 1542. Yeah, I took a lot of time to explain why we're gonna do it like that. Yeah, but I still think this explanation is enough to solve the problem. So let's just start coding. The coding gonna be similar, just like a pattern. So we're gonna prepare index. So from beginning, it's gonna be -1 times. So we're gonna prepare a mask. So the length of the bit. So how many bits? It's gonna be yeah. Let me check. It's gonna be 1 substituted to 5. 1. It's gonna be shifted to 5 bits to the left, and -1. Basically, this is the result is 31. and plus this one, so the length of the array gonna be 32. 32 is 2 to the power of 5, so that is the total state. So we only have 25 different state. Yeah, so this is gonna be our state. Now we are going to prepare a result and mask. So the result is gonna be 0 because we are checking the maximum, and mask, as always, I will prepare a mask. This is 0 is just for -1. I'm gonna set it to 0. Yeah, it should be okay. Now we're gonna enumerate all the characters. For IC, in enumerate S. Yeah. So I want to update the mask. So I want to check these characters. So if this character in, I want to prepare a set because I want to make it in one time. So it's going to be a set of list string A, E, I, O, U. So we're going to prepare a set. Inside there will be 5 characters. So we just check if this character is a vowel. So if C inside S, now we want to prepare the final result. Let's just update the mask first. So the update would be equal to mask with XOR with 1 shifted to how many positions. So the positions is dependent on which character it is. So we're gonna use a hash table. So hash table with this character. So we're gonna use DC. Now we need to design this hash table. So I'm gonna use a counter to save time. So for IC in enumerate with A, E, I, O, U. So yeah, we must keep the sequence as A, E, I, O, U. Or you can keep other sequences. I think it's gonna be the same. Yeah, but I prefer to use A, E, I, O, U. I will keep this kind of sequence because even you use A, I, O, U, E, I think it's gonna be the same. But I will try it later. Let's start to finish it first. Yeah. Now we are going to update. First of all, we are going to update the mask, and then the result would be the maximum of the result with yeah. So the result would be the maximum result with my with my mask. So it's gonna be I minus D of mask. Yeah, so it is the distance from I to Z. So this distance, this index is Z, because it is like a prefix sum. So I'm gonna use I minus D mask. It is not D mask. It is index mask, because D is just another dictionary. It is just the encoding of A, E, I, O, U to 0, 1, 2, 3, 4, and this index is my hash table. So I have to use the index mask to get the result. Yeah, but this is for the odd, and this is for the even numbers. But what is odd? If it is odd, it is the same as I explained earlier. Yeah, there's no drawing, but if you check the video before, even if it is not a vowel, I mean not even or odd. So here I'm checking this character, it is a vowel inside the set. If it is inside the set, maybe I'm gonna use a vowel. Yeah, so this is gonna be a vowel. Yeah, if it is inside this vowel set, so I'm gonna update the state. The state is the mask, and then I'm gonna check the result. Even it is not a vowel, it is still okay. I can still update my final result. Now I need to store the index array. So the index with the mask should be equal to the minimum of I with an index of this mask. Yeah, and finally I need to return the final result. And let me just run it to check if it works. Yeah. So I need to prepare the counter. So it's gonna be DC equal to I from here. Yeah, there's something wrong. Let me check with that. Set list. This is about if say inside yeah, if say yeah, let me just check what is inside the index vowel and counter D. Yeah, let me just check from these areas if everything is okay. Yeah, so the index array is -1. It is not right because basically I need to set the first one is -1. Others are gonna be infinity. Yeah, so it's gonna be infinity times that. Yeah, I did something wrong. Yeah, the first one is gonna be -1, and except for that, it's gonna be infinity. This is my setting because I always check the minimum with the result. And here I use max. It means if this mask is infinity, basically I still use the result before. I will not update it. Yeah. So the index array is okay. The counter is okay. The set is also okay. Yeah. Now I can run it to check. Yeah, as you can see, it works. So basically, it passed for testing cases. Now I want to change the positions, maybe AEIOU, maybe AEOUI. Let's check the result if there is any difference or not. Yeah, as you can see, the result is the same. I mean, the sequence totally it is okay. No, here I used the set AEIOU. Yeah, here I used a different sequence. Yes, as you can see, the sequence is different, but it is okay because this is a bit mask problem. We just need 5 vowel characters, so the sequence doesn't matter. We can prepare any kind of sequence. We just need to check the different states. It means 5 characters have 32 states. The first state is gonna be -1. I mean the value. The other state gonna be, we're gonna update the mask. We're gonna put it inside a mask. The first state, the first state for index 0 is gonna be -1, and for all other states, which is the mask, it's gonna have the different index, and we're gonna update that. Now let me submit it to check if it can pass. Yeah, as you can see, it passed all testing cases. Now let's analyze a little bit about the time complexity. So for here, this is okay, and this is also okay. This is 32, and this is okay. But here we're gonna analyze the time complexity. This is ON, and here this is a O1. Yeah, this is a O1, and what about the mask? So this is also O1, and everything is just O1. So it means the time complexity is ON. Yeah, because we didn't, because here we basically use the set. If we didn't use the set, it may be 5 times ON. Now we can directly calculate it by using ON time because we didn't incur any extra time. Yeah. So the space complexity, let's just check that. Did we? Yeah, it is 2 to the power of 5. Yeah, so this is the space complexity. I think that's for this problem. Thank you for watching. See you next time.